Last time, we reviewed all the indeterminate forms. Here they are in front of you. We did 0, 0, infinity or infinity L'Hopital rule beginning on Friday last week. We did these two on Monday. Basically, everything have to be converted into the fraction. 0 times infinity, flip it a little bit to get fraction. Infinity minus infinity, create common denominator, factor out something to create a fraction. The last three are the weird ones. So 0 to 0, infinity to 0, 1 to infinity. And last time I spent time explaining why, for example, 1 to infinity is not necessarily 1. So check my previous lecture if you want to know more about this. I just want to go through the example, and then we should be done with the whole 3.7. I just showed you, I have videos on my YouTube channel where I solved your homework problems. Let's do these problems. Those are the tricky ones. So remember function to the function case? I think this is also from your homework. Find the limit. See, in this class now, everything is about derivatives. Even the limits have now derivatives. That's kind of my point. Everything indeed in real life applications have derivatives. Here it is. This is a function to the function case. I remember we were learning how to differentiate it. Function to the function. Do you remember what we used to differentiate it? Logarithms. In general, if there's a power that bothers you, people use logarithms to get rid of that power. So it works. Why not to do that? Well, I'm checking first what case is that. Maybe it's fine. Maybe I'm overthinking. Cosine of 0 is 1. 1 over 0 is infinity. This is 1 to the infinity case. That is indeterminate form because 1 to the infinity is not necessarily 1. I quickly was explaining here. If number, the base, is less than 1, because it's a function that approaches 1. If it approaches from the left, then 0.9 times 0.9 times 0.9 shrinks to 0. But if it approaches from the right, 1.01 times 1.01, it's slowly growing or fast growing, that goes to infinity. So because it's not number 1, it's a function that grows to 1 from left or from the right, we don't know the answer. It's either 0 or infinity, either blows up or shrinks to 0. So, question mark. To figure this out, I noticed that I don't know what to do with the power. So I'm going to think about the function separately like so. I'm like, okay, it's a function to the function case. So I will do function raised to a function. It's funky. It's input to the input. That's how I like saying that. And I don't like this power over there. To get rid of the power, this classical way to do it, you use logarithms, even for limits. Why not? Step 1, let me write it down nicely, like so. Step 2, use logs. I'm telling you, logs are amazing. They are in the list of top 15 most important formulas of the world. It's just log, the property of log. That's how important it is. So we're going to have ln of y equals ln of cosine x. And cosine, oh, let me ask you that. Is it cosine raised to the power? Is it log raised to the power? Or it's x raised to the power? What do you think? What do you think? Yeah. Well, what was the original thing? It's cosine raised to the power because of these parentheses over here. So be careful with that. Like so. Not log, right? So it's input of log raised to the power. That is important because only input of log has this property of getting rid of the exponent by putting it down, which means multiplying by log. So laws of logs were used. ln y equals 1 over x squared is now in front. ln of cosine x. This is my new function. Let's find the limit of this function as x approaches 0. Do you have questions about this step? Because this is something you will see on the exam. Logarithmic differentiation is there already, maybe even several times. So it was a big topic. We cannot not put it on the test. Sometimes it goes to the final too. Let's find, so idea, let's put it like so. Idea, find limit of ln y instead of y. In our case, it was x goes to 0, but whatever the limit is. Then, don't forget to answer the answer will be not the number you get. It will be e to the result. Let me not put it as the answer. To the result. Oh, you know, let me put it like this. Let me find limit of that. Let's call it n. Then the answer will be e to that n. So don't forget to undo the limit. Does it make sense what I just wrote? Let me know if it's weird. English-wise and then math-wise, does it make sense? Idea-wise? So let's do that. 4. I'm looking at the limit as x approaches 0 of 1 over x squared ln cosine x. Before you choose what to do and before you feel upset and ditch everything and go play video games, you're supposed to check what case is that. Like, don't get discouraged. Just check what case is that. That's why we listed them for you. We listed the cases for you because that's how people usually see them. They check the case. This is a good case. Yeah, we differentiate. This is like okay case. You need to figure out how to make fraction out of it and then differentiate. This one is like nah case because it probably uses log. And then it takes me still to the, actually let me keep it, it's kind of funny. And then it takes me to the L'Hopital rule again. So those are your 3 types of cases. Let's see. I don't know what case is that. At 0, I have infinity multiplied by log of cosine. Cosine at 0 is 1. ln of 1 is at 1. E to what gave you 1? Yes? 0. Let me write down. ln of 1 is 0. Because there's an e at the base, so e to the 0 gives you 1. So ln of 0, right? So we have 0 times infinity case. Do we know the answer for that? What is 0 times infinity? Do we know the answer? Is it just like 0 times anything is 0, right? No, infinity times everything is infinity. So that's one of the cases. I'm just trying to mess up with you. It's one of those cases when you need to convert it into fraction. So that's like case. It's not too bad. It is like case. It's not too bad. I'm afraid if I leave this weird, people will not understand later what the heck is that. So it's like okay case. We know we need to convert it into a fraction. Right now, it is, if you put this in the numerator, it is 0 over infinity, right? So how should I rewrite it to have a fraction? What kind of fraction? I want infinity over infinity or 0 over 0. What do you think I should do?
Just keep it as logarithm of cosine x by x squared.
By over what?
X squared.
X squared, like so. So actually, it was already a fraction. It just either you see it like these 2 functions or you see it as a fraction. Let's check if it fixed the situation because it's kind of too simple, suspicious. And it's too simple, suspicious. ln of cosine, we already agreed the whole thing goes to 0. X squared at 0 goes to 0. Oh, now it's 0 over 0 case. Isn't clever? So 1 over 0 was infinity, but now 0 is in denominator. So it's 0 over 0 case. I can use L'Hopital rule. Everything goes back to the Mr. L'Hopital rule. All the limits go to hospital. Did you see the meme I posted? Well, if you not, you should check my announcement. That's how I know if you check my announcements, if you see the meme or not. So, what do we do now? We differentiate. Separately, it's not quotient rule. That's on a test already. You differentiate the top, differentiate the bottom. Didn't I told you before that log is the slowest one, so x squared wins? Well, it's only at infinity. So make sure you don't forget that. Around 0 or any other number, even minus infinity is gonna sketch it. You should actually perform L'Hopital's rule or think harder. But at infinity, x squared would win. So it's 2x, and now we're checking your knowledge of derivatives. So all those kind of derivatives are on the test everywhere. ln of u gives you 1 over u. And then it says times u prime, derivative of the function inside, minus sine x. Looks horrible. Let's see if maybe it's fine. Do you agree with the derivative?
Yes.
Well, yeah, I know. I'm just like trying to see the faces. Okay, most faces do not look scared, but that may be because they're sleepy. 2x, and now let's simplify. It's going to be minus sine x over cosine x at the top, and I changed the color to green. So sine at 0 is 0, cosine at 0 is 1. So it's still over 0, 0 over 0 case. It's not really help. If it happens, you can perform L'Hopital rule again. And then if it's 0, 0, infinity, infinity, again. So now I want to differentiate top and the bottom again, separately. 2x is easy, but sine x over cosine x is going to be a quotient rule. Do you want to perform quotient rule? Or let's use tangent. So before, that's what I wanted to tell you. Before I perform L'Hopital again, let me rewrite it first. It's going to be minus tangent x. Likely, you know derivative of tangent. Do you? Okay, good. It's all over exam. All those, we put lots of arcsine and arcsecant and arctangent there. Actually, originally there was arccotangent on the test, and I'm like, yeah, that's too much. Arctangent is not hard, and arccosine is not hard, but it's like not required actually. So you're required to know 3: derivative of arcsine, secant, tangent, arcsecant, arctangent, because they will go to the future material, and everything goes from them. So that's like the base you need to know. So now a derivative of the bottom is 2. Tangent gives you what? Secant squared with a minus in front. Now check again. Well, 2 is finally a number. So not only you cannot perform L'Hopital rule anymore, it's not going to be 0, 0, infinity over infinity. It's definitely a number. I just need to figure out what is the number at the top. Secant 0. I don't remember what secant 0 is. And it's actually true because, as I told you, in other countries, not all of us do have secant and cosecant functions. We just know 1 over sine, 1 over cosine. So why bother? I am not bothered by memorizing what secant 0 is. Or pi. There's just too much stuff to memorize. And that's why I don't take a chemistry class. So I just know the formula though. Secant is, if it starts with S, it will be C, 1 over cosine. And I know these guys. I know what cosine of 0, that's 1. So secant at 0 is 1. 1 over 1. So it's minus 1/2. And that's the answer. Can you do that on a test? No?
Is that the answer, or we still have to solve for y?
Very clever.
The power.
Yeah, very clever. I usually ask and you kind of spoiler my question. You even have 2 spoilering people over here. They just keep spoiling. So, spoiler alert just happened, but maybe nobody heard it. Let me see. Is this the final answer though? No? Okay. It's not. I'm trying to make it exciting. I'm sorry. It's just that kind of material. So, as I mentioned here, be careful with this. It's not the final answer. We used log as an intermediate helper. It's a tool. Log becomes a very convenient tool to get rid of exponents or work with exponents. But then if you use log, and then we found limit of log, that is possible because of continuity of logarithm function. It's continuous, it's nice. Limits work well with continuous functions, la la la. So what we know, since we use log, we need to undo log. That's what I'm trying to say in an annoyingly long way. So to undo it, how do you do log? You put e at the answer. So the final answer is e to the minus 1/2. Let me make it look better. Final answer. Answer is e to that number we found, which is e to the minus 1/2. Not just minor detail. I know it's probably going to be easy to forget because we put lots of effort just now into finding that one. And so on. All of those questions will be the same. You use log again, you use log again. Summary. I have more examples in my notes. You can definitely check that. Summary is 0 over 0, infinity over infinity, plus minus, we don't care. You use L'Hopital's rule. Yay. That's your favorite one. It will be very good to do it on a test. Your job is to know derivatives because L'Hopital rule works with derivatives. For example, do you know what derivative of log 5x. Let's review that. What's derivative of log 5x? 1 over x and 1 over natural log of the base. I always say it out loud. Natural log of the base. 1 over. You divide by natural log of the base. Do you know what 2 to the x is? Copy and then times natural log of the base. So for the e, for the exponential, you multiply by the natural log of the base. For the log, you divide by the natural log of the base. You need to know those formulas. If you want to use L'Hopital rule and you don't know this, you cannot use L'Hopital rule. Step 2. If you have a product, 0 times infinity, you want to create a quotient. And to create a quotient, you play with the fraction. 0 over 1 over infinity is still 0 times infinity. But now you can see it as 0 over 0 case. 0 over 0 case. Or infinity over 1 over 0, and that's infinity over infinity case. And it takes you back to L'Hopital rule. That's why I put this arrow here. Infinity minus infinity, you also want to take it to a fraction to use L'Hopital rule. So how to do it? Simplify, factor something out, common denominator. Those are 3 steps which we're like, okay. And the last 3 are the one we just did. You do e to the ln, and the answer will be e to that limit. E to the ln or ln helps you to get rid of the power. This power and this power and this power, they go down when you use log. So this is what we just covered. And one minor thing is, do I have it here? No. Those are called indeterminate forms. Again, indeterminate forms. That because, do you guys have questions? That because we cannot determine, it's not obvious to determine the answer for this case. But I wanted to show not indeterminate forms. Are you ready? 0 to the infinity. And again, it's not a number, okay? Remember, it's f to the g. F goes to 0, g goes to infinity. Is this determined, not determined? Well, it's just still, it's 0 times 0 times 0, blah, 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 times 0, infinitely many times. So that is 0. That is not an indeterminate form, for example. So you see? It's kind of not obvious something. Now you question everything. If I were you, I would question everything now. Infinity to 1. Again, it's not infinity raised to number 1. It's a function that goes to infinity and a g that goes to 1. Still infinity, because it's infinity once. A function that goes to 1 and the function goes to 0. It's 1. And infinity, function goes to infinity, and then there's a function that goes to infinity. Guess what? That's infinity. So those are not indeterminate forms. You don't have to memorize this. It's just common sense for these cases. And again, remember, I will be repeating it many times. It's a function to the function. While the other cases are indeterminate. Yes?
No, I was going to ask the infinity to infinity. It's also a function to the function.
Yeah.
But if both of them are going to infinity, the answer
Yeah.
is always going to be?
Yeah, because that's a good question. So the question is f, looks like so, limit of f to the g, x approaches a number, anyway, let's say infinity. So this guy blows up to infinity. The base blows up to infinity. That means huge numbers raised to the huge numbers. Doesn't matter how big they get, they will be infinities. Yeah, so that's why it makes sense. Thank you for asking. Good job, people. Any questions? That's 3.7. I just mentioned that other homework problems are solved in my channel. That's why I could save time. And then we have exam on Monday. Exam review is already recorded for you, posted. I cannot make it better than that one. It's just so good. So I highly recommend to watch it. And you pause before I show, before I solve the problem. I leave it like so. You pause, solve it yourself. Play, see the answer, and then check your solutions. That's the best way to watch videos in general, not just mine.